Today, a new revelation has surfaced. The James Webb Space Telescope has detected light from an Earth-like planet. The James Webb Space Telescope, humanity's most advanced and ambitious space observatory, has been on a mission to explore the deep recesses of the cosmos, unearthing secrets that lie billions of light-years away. This sentinel of the stars has recently achieved a remarkable feat, making a discovery that brings us one step closer to answering one of humanity's oldest questions. Are we alone in the universe? The telescope has detected infrared light from a rocky exoplanet known as TRAPPIST-1b. Exoplanets are planets that orbit around stars outside of our own solar system, and TRAPPIST-1b is one such celestial body, albeit with some remarkable characteristics. Unlike our home planet, TRAPPIST-1b lacks an atmosphere. This absence of an atmospheric blanket makes it a unique subject of study, offering us a rare glimpse into the raw, unshielded nature of an exoplanet. But that's not all. TRAPPIST-1b sizzles with a staggering surface temperature of around 230 degrees Celsius, significantly hotter than any environment we're familiar with here on Earth. The detection of infrared light from TRAPPIST-1b by the Webb telescope is a monumental achievement. It provides us with a new perspective on these distant worlds, allowing us to study their physical properties and atmospheric conditions, if any, with unprecedented detail. This discovery marks a significant step in understanding exoplanets and their potential to support life. While TRAPPIST-1b may not be suitable for human habitation, its study brings us closer to understanding the conditions necessary for life's existence beyond our blue planet. And who knows what other revelations await us in the infinite tapestry of the cosmos. Diving deeper into the specifics, let's explore the intriguing features of TRAPPIST-1b. This celestial body, an exoplanet, is quite a unique character in our cosmic drama. Nestled within the constellation of Aquarius, TRAPPIST-1b is a rocky exoplanet that orbits a small, ultra-cool dwarf star. This star, although smaller and less luminous than our Sun, is the heart around which TRAPPIST-1b faithfully revolves. What sets TRAPPIST-1b apart is its Earth-like qualities, specifically its rocky nature, which is a feature shared by our own home planet. However, don't let this likeness fool you into thinking we've found a second Earth. Like many characters in our cosmic tale, TRAPPIST-1b has its own quirks that make it distinct. The biggest of which is that it lacks an atmosphere, a crucial element that supports life as we know it. This absence of an atmosphere subjects the exoplanet to extreme conditions, making it unsuitable for human habitation. Another noteworthy factor is the planet's temperature. With a surface temperature averaging around 230 degrees Celsius, TRAPPIST-1b is a far cry from the temperate conditions we enjoy on Earth. This scorching heat, far hotter than the highest temperature ever recorded on our planet, is another nail in the coffin for the possibility of human habitation. Despite its close proximity to its parent star, TRAPPIST-1b is not in the star's habitable zone, the region where conditions might be just right for liquid water to exist on a planet's surface. The planet's close orbit around its star also results in extremely short years, with a single orbit completed in just over 1.5 Earth days. While TRAPPIST-1b might not be our next holiday destination, its discovery is still a giant leap in space exploration. Each exoplanet we uncover adds a new piece to the puzzle, bringing us one step closer to understanding the complexities of our universe. So, why does this matter? What's the big deal about finding light from an Earth-like planet? Well, it's all about what this light can tell us. When light from a star passes through an exoplanet's atmosphere, it carries with it a unique fingerprint. This fingerprint, or spectral signature, can help us decipher the composition of that atmosphere. And that's exactly what the James Webb Space Telescope has done with the exoplanet TRAPPIST-1b. This detection of light is a game changer. It's the first time we've been able to detect infrared light from a rocky, Earth-like exoplanet. Though TRAPPIST-1b may not have an atmosphere and is too hot for human habitation, this discovery is nonetheless significant. It's akin to a detective finding a crucial piece of evidence, pointing us towards a greater understanding of these distant worlds. And let's not forget about the potential implications for the search for life beyond Earth. After all, the conditions for life as we know it hinge on the presence of certain elements and compounds, many of which leave their mark in a planet's spectral signature. By studying these signatures, we can begin to identify which exoplanets might just have the right ingredients for life. But the importance of this discovery extends even further. It's not just about one exoplanet, it's about the potential to use the same method to study countless other exoplanets. Each detection, each light signature adds another piece to the vast cosmic puzzle we're trying to solve. So, we come back to our original question. Why does this matter? Because each piece of light detected from an Earth-like planet brings us one step closer to understanding the universe and our place within it. Each detection pushes the boundaries of our knowledge, driving us to explore further, to question more, and to continue our relentless pursuit of the unknown. This discovery is not just about TRAPPIST-1b, it's about the doors it opens to understanding countless other celestial bodies. With this discovery, the future of space exploration looks brighter than ever. The detection of infrared light from TRAPPIST-1b by the James Webb Space Telescope is more than a scientific triumph. It's a beacon of hope, illuminating the path to our future among the stars. Our understanding of exoplanets, those celestial bodies orbiting stars outside our own solar system, is significantly enhanced by this discovery. The ability to detect light from these distant worlds provides us with a new lens to gaze into the cosmos, deepening our comprehension of these fascinating objects. This knowledge is critical as we plan future missions to these worlds. But this discovery isn't just about preparing for future missions, it's about broadening the horizons of our understanding. By detecting light from Earth-like planets, we can begin to unravel the mysteries of potential life beyond our home planet. It's a tantalizing prospect that could redefine our place in the universe. Moreover, this breakthrough has the potential to influence the direction of future research. It's a stepping stone that could lead to the development of more advanced telescopes, capable of capturing even more detailed data from these distant worlds. Who knows? In the years to come, we might be able to detect even the faintest signs of life on these exoplanets. This is an exciting time for space exploration. Each new discovery is a testament to human ingenuity and our unquenchable thirst for knowledge. With each passing day, we're pushing the boundaries of what we thought was possible, reaching further into the cosmos than ever before. As we continue to gaze into the cosmos, who knows what other wonders await us? This study, a culmination of tireless effort and cutting-edge technology, presents an in-depth analysis of the infrared light detected from this rocky exoplanet. This exoplanet, while not suitable for human habitation due to its lack of an atmosphere and high temperature of around 230 degrees Celsius, provides a wealth of information about the universe we live in. The findings are intriguing, to say the least. The detection of infrared light from TRAPPIST-1b is a testament to the capabilities of the James Webb Space Telescope. It's a glimpse into the future of space exploration, a future where we can study distant planets in detail, and perhaps one day, even find one that could support life. As we draw this cosmic journey to a close, it's important to reflect on the magnitude of this discovery. We've ventured together into the depths of space to the exoplanet TRAPPIST-1b, where the James Webb Space Telescope has detected infrared light. This seemingly simple observation marks a major milestone in our understanding of exoplanets and the potential for life beyond Earth. As always, stay curious, keep exploring, and we'll see you in the next video.